Hey folks, in this lecture we will learn how to build a simple AI-powered chatbot using Python. We'll train it with real-world questions and answers about America, connect it to a smart model, and create a user-friendly chat window using Tkinter, just like talking to your own mini ChatGPT.
Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Let's start it by opening PyCharm IDE. Inside PyCharm, we have already created a project named Chatbot. Within this project folder, we have a file called QIAdata.csv. This file contains 5,000 questions, each matched with a correct answer. All of these questions are related to information about America. They cover topics such as U.S. history, geography, government, famous landmarks, presidents, states, and national symbols. You do not need to use all 5,000 questions to start building our chatbot. To keep it simple in the beginning, you can select just 5 to 10 questions to train our model. These smaller samples are enough to test whether our chatbot is learning properly. The questions you choose should be clear and direct, so the machine can understand them easily. For example, we can include questions like, what is the capital of the United States? Who is the current president of America? Or what is the national bird of the United States? Now that we have these sample questions and our CSV file is ready, we can move forward and start training our chatbot using this data. But before we start working with the AI model, we will first create a simple interface for our chatbot using the Tkinter framework. This interface will allow us to ask questions and view responses in a user-friendly window, just like any basic chat application. For this, we will create a new Python file inside our project folder and name it chatbot GUI. Inside this file, we will paste the GUI code that builds our chatbot window. We are not writing this code from scratch because we have already learned how to design basic interfaces using Tkinter in the previous sections of this course. So, this code starts from the Tkinter module, which is used to create a simple graphical interface. We started by creating the main window using the tk.tk function and set its title to AI Chatbot with a fixed size of 500 by 500 pixels. Inside the window, we add a large text box named chat log, which will show the conversation between the user and the chatbot. This is set to read only using state equals tk disabled. Below that, we create a frame to hold the input field and the send button in a horizontal line. The user input field lets the user type a message, and the send dash button is created next to it, but currently does not perform any action. Finally, we use root.main loop function to start GUI and keep the window open so we can interact with it. Let's run this code to see how it looks on the screen. Here you can see that the chatbot window appears with a clean and simple design. At the top, we have a blank area. This is the chat log box where all the messages will appear during the conversation. Right below it, there is a small white bar. This is the input field where we can type our questions. And on the right side of the input field, there is a send button. Currently, the send button is visible, but it doesn't perform any action because we haven't connected it to the model yet. This layout gives us the basic structure of a chatbot. And now we are ready to connect it with our AI model so that it can give real responses. Let's move on, and first we go to the top of our program where we import the modules. We write from tkinter import message box. This means we are importing a tool called MessageBox from the Tkinter library. The MessageBox tool is used to show pop-up alerts. For example, if our program cannot open a file or something goes wrong while reading the data, we can use a message box to show an error to the user in a neat pop-up window. After that, we import the pandas library. This library helps us to work with data stored in tables, such as data from Excel sheets or CSV files. In our case, we are going to use a file called QUAdata.csv, which stores questions and answers. This file has two columns, one for the question and one for the answer. The pandas library will help us open this file, read the data inside it, and turn that data into something we can use in Python, like lists. Next, we import tfid vectorizer from a library called sklern.featureextraction.text. This tool is used to convert text into numbers. Why do we need to do this? Because computers don't understand words the way we do. They only understand numbers. When we give the computer a sentence, we must first change it into a form it can read. The tfid vectorizer helps us do that. It looks at each word in a sentence and gives it a score. The score is based on how often that word appears in all the text we have. The more important a word is, the higher its score. Words like what or the are common and don't help much, so they get lower scores. Important words like capital, eagle, or president get higher scores. So this tool helps us convert our natural language into something a machine can understand. We then import logistic regression from another part of the same library. This is the machine learning model we are going to use. A model in AI is like a smart brain that learns from examples. We are going to give it many questions and their correct answers, and the model will learn how to match new questions to the right answer. Logistic regression is one of the simplest and most widely used models for this type of task. Even though the name has the word regression in it, it actually works well for predicting categories, like matching a question to an answer. Now that we've imported everything we need, we define a function named loadData. This function is used to open our CSV file and get the questions and answers from it. The function takes one input, called file path, which is just the name of the file. Inside the function, we use pd.read.cse parentheses file path. This uses pandas to open the CSV file and turn it into something called a data frame, which is like a table of data in memory. We save this table into a variable named df. Next, we want to take the column named question from this table. Here we get the column named question. Turn everything in that column into strings, and then convert the whole column into a list of questions. We store this list in a variable named questions. In the same way, we take the column named answer, convert it to text, and turn it into a list, which we save into another variable called answers. After getting both the questions and the answers, we use the return keyword to send both of these lists back to the place where the function was called. But before that, we write the function inside a try except block. This is done for safety. If there is any problem while opening the file, like if the file does not exist, the program will not crash. It will run the code inside the except block and show a pop-up message using messagebox.showError. This pop-up will show the error message so the user knows what went wrong. If an error happens, we return two empty lists instead of actual data. Now that we've defined the function, we use it by calling load data parentheses QA-data.csv. We give it the name of our file. If the file is correct and everything goes well, we get two lists, one containing all the questions and one containing all the answers. These lists are saved into two variables named questions and answers. After loading the data, we move on to the next part, converting the questions into numbers. We do this using the TF-ID vectorizer. First, we create an object of this class. This object is now ready to convert any text into a group of numbers based on the importance of each word. We then call fit a short transform parentheses questions on this object. The fit part means we are asking the vectorizer to learn from our list of questions. It looks at all the questions and understands which words are common, which are rare, and how important each word is. The transform part means it turns each question into a vector, a row of numbers. These numbers represent the pattern of words in each question. We save this result into a variable named x. This variable now holds the numeric version of all our questions. This is the input we will use to train our AI model. Next, we create an object of our AI model by writing model equals a logistic regression. This model is now ready to learn. We train it by calling model dot fit parentheses x answers. The fit function is used to teach the model. We give it the numeric questions from X and the correct answers from the answers list. The model looks at the patterns in the numbers and learns which patterns lead to which answers. This is the heart of the training process. After this line runs, our model is trained and ready to make predictions. Now that our AI brain is trained, we want to use it to reply to user input. For this, we define a new function called sendMessage. This function will be connected to the send button in the GUI. It will run every time we click that button. Inside this function, we first get the text that the user typed. We do this using user input.get function. This reads whatever is written in the input field. We then use the strip function to remove any extra spaces before or after the text. If the input is empty, we simply return and stop running the function. If the user has entered something, we open the chat log by setting its state to normal. This means we can now insert new text into it. We use chat.log.insert to show the user's message in the chat window, adding the words you before the actual message to make it look like a real chat. Next, we need to prepare the user's message for the model. Just like we converted the training questions into numbers, we now do the same with the user's input. We use the vectorizer dot transform function to do this. First, we convert the user input to lowercase letters. This helps avoid confusion with capital letters. Then we pass it into the vectorizer, which turns it into a vector, a row of numbers. Once we have the numeric version of the user's message, we use model predict parentheses user vector to ask the model what the answer should be. The model looks at the numbers, checks the patterns it learned during training, and gives us the answer it thinks is best. This answer is stored in the variable prediction. We then display this prediction in the chat log, again using chat.log.insert and write bot before the answer so it looks like the chatbot is speaking. If any error happens while making the prediction, maybe because the input was too strange or the model couldn't match anything, we use an except block to show a message saying the bot doesn't understand. After that, we lock the chat log again using chatlog.config parentheses state equals tk.disabled so the user can't type directly into it. We also clear the input field by calling user.input.delete parentheses 0 tk.n. This prepares the interface for the next question. This whole setup, loading questions, training a model, and predicting answers creates a working chatbot. It learns from the data we give it and then uses that knowledge to answer new questions, even if they are not exactly the same as the ones in the file. Finally, we go back to the GUI and look at the Send button. This button appears next to the input field and allows the user to send their question. But by default, it doesn't do anything when we click it. To make it work, we add a command to it, which tells the button what to do when it is pressed. We connect it with our send message function. So every time we click the button, that function runs. This way, the message is sent and the bot gives a reply in the chat window. Now let's run this program again. As soon as we run it, the chatbot window appears just like before, but this time it is fully functional. That means it is not just showing a window, it is also connected to the trained AI model. So it can now understand our question and reply with the correct answer. Now let's type the first question that we used when we trained our machine. For example, we type, "What is the capital of the United States?" and then click on the send button. As soon as we do this, the chatbot gives the correct answer, Washington, D.C., which means it understood our question properly. Now let's change the same question a little bit and try saying, "Name the US capital," or "Which city is the capital of America?" or even just "Capital of America." These versions are not exactly the same as what we wrote during training, but they all mean the same thing. Here we can see that the chatbot still gives the same correct answer. Washington, D.C., every time. This means our machine is not just memorizing exact sentences, it is learning from the patterns of words and how they connect to the correct answer. It uses something called the TF-IDF vectorizer, which looks at the important words in our question and turns them into numbers. The model we trained, called logistic regression, learned to match those numbers to the right answer during the training process. So when we give it a new but similar question, it looks at the pattern, compares it with what it saw before, and gives the best possible answer. This is how machine learning works in simple words. We give it many examples to learn from, and once it learns the pattern, it can answer similar questions all by itself. See you in the next section.